I'm cutting down a commercial boring bar that's got a 3/4 inch shank, and I'm gonna cut a section out of it. That's what we're doing here. For the Wohlhaupter rotary milling head, angle cutting head. This is a Criterion brazed carbide boring bar, and the material is really quite tough. And I'm machining it with micro 100 carbide, and running pretty slow for that diameter, under 3/4 inch at 473 RPM. And it's turning the chips purple. That's some pretty tough steel. It'll take me a few passes to get down here. I got a little over 100 thousandths to go. So the shank's back in the chuck there, but I'm making use of this heavy-duty little 4-jaw. It's just really nice for this particular job. A good solid hold on tough material, and of course the good old micro 100 carbide doing the cut. Okay, we'll get back over to that boring head. Okay, I got that tool shank reduced to fit the head here, and cut off from most of it. Now we're gonna test it out first, cutting a 45-degree hole or somewhere in there. And here's the directional arrow, and it'll go from 0, feeding straight, on over to 90, and the block will feed that way. And there's some interesting things about that I'll get into. But I think the first thing to do is to cut angled holes. And if you can see my protractor here, with the tool traveling along that 45, it looks like there's plenty of clearance, so we'll sharpen it up on the cutter grinder here. Okay. I've got that head pointing straight up because it oils. I can oil it up here and it runs down. It just got a little bit dry. Yeah, it oiled the upper parts here. And it hopefully drains down to the feed collars here, which it has. This is getting real smooth. We'll run it through its paces here. Okay, back it a bit. All right, got a new belt on the grinder here. It is running very smooth. There's Chloe. What are you up to? Did you eat all that stuff? She wants more. She'll have to wait a little bit. We're going to come around here, and I think I can set the camera right in here, and you can see me grind this thing. A little more light over here. Okay, I'm going to take the white dressing stick that's not as white as it used to be, and clean that diamond there. I'm going to turn on the vacuum. I got a vacuum here that'll catch most of this. Yeah, it's doing a good job there. Okay, let's start feeding it in. I give it about 12 degrees clearance. get my get it up close there. I'm changing that lead angle. I'm going to give it a positive 3 degrees lead. Let me just see if I can get that up there. I can't see very good from here. Get that up to that wheel. At least so it touches. It looks like it's going to touch it any moment, but it don't. So this is a tool for the Wohlhaupter UK4. I can't believe how far away that was. There we are. I'm going to grind away on the heel on that tool just a little bit, and it'll give it that positive lead. Vacuum's picking it up good. And I don't smell the carbide. You get this carbide dust in the air, you can definitely smell it, and you can taste it. And they say when you can taste it, you are thoroughly contaminated with it. At least by that time you taste it. Not quite touching the tip yet, almost. Once I touch that tip, I have to grind it back about 5 thousandths or a little more. A lot of times I can look at this with a mirror. I don't know if I have that handy to look at that back side there a little bit. But I'm going to guess I've got this thing. Okay. We'll just pull it out and have a look. I got it. Yeah. Even bit into the steel a little bit there. That's okay. This is a utility wheel. I'll get it over on that belt sander when it needs sharpening again. And give it that clearance it needs for the grind. That looks good. Okay. Did that in the V-block and the all-tool Rotary fixture. Well, this is the number 2 Brown & Sharpe milling machine that we will run the UK4 Rotary milling taper boring head. It's a mouthful, I tell you that thing, but it's quite a gizmo. And we'll have a close look at it here. But first, let's have a look at this old machine. So I'll take this loose here from the Gitzo tripod. And first, it's a horizontal number 2 Brown & Sharpe milling machine, but it's a wartime machine. And what's different about this machine is they took an older design. The main body of it is a 1930s design, about 10 years older. This is about 1942 or 3. And put a modern knee on it with, or a semi-modern knee with a motorized knee. And the old original mills with this casting would use a mechanical drive to the table and transmission instead of electric motor and the shifting right here. That's familiar with more modern milling machines. And at the time, they made the #2 mill with a lighter body, and they called it a light mill. And so this was referred to as a heavy mill. This weighs about 5,000 pounds, and their #2 light mill weighed, I don't know, 3,500 or 3,700 pounds. So this is kind of an interesting historic machine. And it came out of Hanford and purportedly the Manhattan Project era. And what's kind of different about this machine is this attachment here slides. It's driven by a spline here, and I don't know if it's out of gear, it's out of gear. And on the rams here, this will extend out so you can move the position over the table, but you lose a lot of height with this. And as a matter of fact, the knee is all the way down, and that's how much room we got for work here. So there's some kind of interesting things about a mill like this that can be overcome in many different ways. And this horizontal vertical attachment has a #40 taper, and the horizontal main spindle is heavy-duty 50 taper. Okay, so I'll get a chair and get comfortable, and we'll start getting into the details of this head that was kindly donated to this channel by Jan from the UK. Okay, be back in a second here. All right, welcome to my world of Wohlhaupter here. And over here on the left is a UK4 I believe that's the number on it. Let's see if we can write it. Maybe it's on the other side, but you know, it's a UPA5 jig bore, boring and facing head. Now, this one, like the rotary milling head we're featuring in the video, feeds from a collar. So this collar, you can hold it stationary with a rod, and this has that same spot there, right there, and bear the rod against the machine, and then this thing rotates. This collar stays stationary, and the head, the only automatic feed that the head has is this way, horizontal. And you affect the feed by pushing in one or more of these 12 pins. And you can see this one's pushed in. And each pin that you push in feeds the head laterally or horizontally 1/2 thousandths of an inch. So if all 12 pins are pushed in, then the head will feed 6 thousandths. So one of the things I'm getting at here is with this head here, and I don't think I need to stick that in. I think I can just rotate it. Now this is freeing up and doing what it's supposed to do. So this head here, when it's adjusted so the arrow is horizontal, works just like this head here. You grab the collar, and it'll feed horizontally. Now, on the Bridgeport mill or other milling machines, this doesn't do that. Doesn't have a quill feed in that vertical head. It's got a crank up there. So there's no power feed to the quill on this machine here. And but if it did, let's say it's like a Bridgeport, and if you set the power feed on the Bridgeport, the power down feed to 3000s, and you pushed in 6 of these pins on the horizontal and got everything fixed down, when you started the machine, the Wohlhaupter head will feed down from the milling machine spindle and feed out on its own mechanism and cut a 45-degree angle. It'll do the same thing with reduced. If you have 2000s feed on both down and horizontal, it'll cut a 45-degree angle. So you can vary the horizontal feed, and you can vary your power down feed on your quill and cut fixed angles, because the power down feed is in steps. And the same with the head here. So you can cut 45, you can probably get 30, and cut some other angles. And I've done that before for like chamfering big things and putting angles on things. It's not that hard to do. You just juggle your quill position and the position of the slide. And here's where this is a little bit similar to this head here. So both of these are doing the same thing. You can see the horizontal ways here, but what this head has, this doesn't. It has some vertical ways. So it's like double the complexity of this head. But it's kind of simplified in some other aspects, like it's only got one feed rate, where this goes from a 0.5 to 12 or 6,000. This only has a feed of 2,000 per revolution, or it's got a rapid traverse for returning the tool to start. And we have to go through all this stuff. And I could really kind of get things a little bit complicated getting into this, but it's really pretty simple once you get used to the Wohlhaupter way. Okay, so when you're operating this head here and it gets engaged, you can return it to start with this screw here. You stick an Allen wrench in there, but you got to jiggle it, and then it lets go of the clutching mechanism. You can feel it let go, and then you can quick position the slide. And then when you continue to use the collar, it automatically re-engages and starts feeding again. So that's just kind of part of how these things work. Hold on a second, I want to get a drink of coffee. Okay. So I was going to bring out the tree angle cutting head, but that's like another thing, and I'll pull that out because later we're doing different cuts with this, and we can do cuts with all three of the heads too. This has got a 40 taper shank on it. It'll fit up in there. Let's see what else. So Okay, back to using the lateral feed and the down feed at the same time. If they're equal, they'll cut at 45 degrees. Well, Wohlhaupter used that equation in the design of this. So this head, you can turn this here. Now it's going to feed vertically. And it will only feed vertically, and it won't move the horizontal slide at all until you start going over this way and add an angle like 30 degrees. Then the head's gonna, as it's rotating, the center block here, this is what I mean by the center block, this will not only feed down, but it'll feed out. So it's not tilting anything like the tree head. It's going by feeds, like cutting at 45 degrees using the basic facing head in combination with your power down feed. Okay, on a mill that has that. Or then you can fiddle it around and cut some basic angles and get it back at the start and jiggle with this and get the slide in the right place and cut again. Now this, what's really a strange thing, I go, did I break this thing? So let's put this back in the horizontal. Let's see if I move that too much. There's a trick to getting this in the right spot. You got to have it sticking out about a 1/4 inch, protruding down this way, and within about I don't know, 3/8 of an inch either way this way. So here, this thing will feed horizontally, and I'll turn it a few times and you can see it do it. Let me hold on to it. Oh, it's not going to go that. Oh, it's not going to kick in. Maybe it will. Okay, you can watch it feed there. Right here, see the center block here is disappearing into the casting. And it'll feed back. So it's also got this screw here, remember, that's got a clutch on it. But when it's in horizontal, in horizontal mode, this is totally disconnected, and it just doesn't move this. But if you rotate this to an angle, or have it straight down, let's see. So see, sometimes if you jiggle something, it'll get a little bit stuck. Let's see if I can, there we are. See if I can get this all freed up. Here we go. I jiggle this, pull down there. Just pull down on it a little bit. Okay, now let's say I have it about 45 degrees right there. And I'll start feeding it. And you can see it's starting to come down. This is rapid traverse here, 40 thousandths per turn. And I'll talk about how to get the actual feed going. It's kind of interesting in itself. Okay, now this screw has re-engaged. So it can position the horizontal. You see I'm screwing it in there? So this is important when you're working. It has just under a 1/2 thousandths of travel with this screw. See, I can screw it out. My shoulder's snapping out of joint if you're hearing something weird. Hey, Chloe, knock it off. She's got to quit that. Okay, so you can use this screw to position it only if it's in other than horizontal feed. Okay, I'll be back with another angle. I'm going to go deal with the dog. Now, unfortunately, the GoPro's not a very good close-up camera, but I hope you can see some things anyway. Now, this is the feed collar here. There's 2 of them. You lay down there, Chloe. You be good. Lay down. I just yelled at her for barking out there. So these 2 feed collars are locked together with this pin here, and that makes it rapid traverse. Now, the top collar here has a rod. So if you have a rod fixed to the machine and it comes to the end of travel, this little pin here acts as a clutch. Let me get that, this little screwdriver will get under it. Okay. Now the top collar is independent of the bottom collar. And they're not connected at all until you push in this button here. Now this is interesting. So I'll see if I can get it pushed in. It pushed in. Now, when it's like the top collar is like back geared to the bottom collar. So if you grab this top collar and this is rotating, in one turn it'll feed 2 thousandths. With it locked together, this out, kind of like an old bench lathe, this out and this in, then it's in direct, and each rotation is 40 thousandths. So this is a considerable reduction. Okay, now this is also how this works too. So it's rotating, looking down at the hole clockwise, cutting. And you got a hold of this collar here, and this collar's rotating the opposite direction and feeding this at 2 thousandths. Okay? So when you get to the end of the hole, at the end of the travel, these stops automatically kick out. This one will kick out here. It's in fine feed. This will pop out. Then this one's popped out, and it won't do that fine feed. So you can do rapid traverse. See if I can find 0 here. Get that top pin pushed in. It's really hard to see back here. There it is, right there. Now the 2 collars are locked together. So when you reverse it to go back to the beginning, then it's rapid traversing back to the start. So you would rapid traverse back to the start, and then adjust your feed for a deeper bevel cut, which would either using the quill or lifting the knee. Then you could go for another cut. You can use this adjustment to get the tool in the right place to start anyway, or if you stop and start or doing something else. So that's kind of the basic function of this thing. And I'm thinking about the best thing to do now is find a piece of metal and bevel a hole in it and do some general cutting that way. At least get started. Let's cut a 45-degree bevel on a hole. Okay, we'll get this cranked up and going. Well, we'll get more familiar with setup of this device as we use it. Okay, I'm going to cut a substantial 45-degree bevel on that hole. That hole right there. And what I'm going to do is make sure it's ready to go. I got the slow feed button going there. So when I grab this top collar, see that bottom collar turns slower. It's like it's a back gear or something there. So we're ready to go there. We'll get the machine in gear, in back gear, and we'll start it right here. Lift up on the lever. And follow the line of power there. Okay. So let's cut that hole. See if I can get that camera in a good spot. Okay, I'm grabbing the ring and it's starting to feed. It's a 2/1000ths per turn feed. You can see it's starting to cut now. Cutting a 45-degree bevel. Okay, it's cut that. Now to pull down for the brake. Let's see, I better... No, it's okay. I don't think I need to take it out of gear. So we're going to take it out of that feed. This button has to get pried out. I can find the right grab on it. There it is. Okay, now it's out of the feed, and this top collar is independent, and it's easier if you push this button in. You could just grab both collars, but I believe I can just grab the bottom collar, and it will rapid traverse to start. So let's try that. Here we go. Oh, got to get it in gear. No, I left it in gear. Here we go. Okay, so now I'm going to grab the bottom collar, and the tool's going to rapid traverse out of that hole back to the start. So this will cut any angle from 0 to 90. And I cut on the back side. Let me get this back out. Now I cut on the back side of center here. See? If I flip this tool around and put it in front of center, then it would cut an external cone. Okay, that's something to think about, and I will be back with quite a bit more on this head and making special tooling for it, like for cutting O-ring and snap ring grooves in holes, and external, internal cutting. Okay, thanks for tuning in, and see you on the next one.